At the factory, VCU is provisioned with the VCU private key, VCU public key and the signature by OEM. This signature by OEM is signed by an OEM private key. Whereas BMS ECU is provisioned with the OEM public key so as to verify the signature by OEM for authentication check. Now at runtime, as vehicle starts, first thing that BMS ECU is going to do is check authenticity and authorization of VCU it is communicating with. And for doing so, VCU will send the provisioned VCU public keys in it to the BMS over CAN protocol, and after that VCU will send the signature by OEM which is provisioned in it from factory to the BMS node. Upon reception, BMS will verify the signature of OEM so as to ensure it is authorized VCU it is communicating with, and if verification passes, it means VCU is OEM authorized and VCU public keys are provisioned in the BMS for further use. Now to ensure this is not a fake VCU mimicking to be an authorized OEM VCU, BMS will do one more step of verification based on challenge response crypto scheme, and in this BMS will generate a random number using HSE crypto accelerator and send it to the VCU. Upon reception of random values, VCU will generate the digital signature using the HSE crypto accelerator on the random value using its VCU private key. Once signature is generated, signature is sent back to the BMS. BMS verifies the signature using the digital verification crypto scheme supported in HSE using the VCU public keys which are provisioned in it initially. And if this verification also passes, it confirms that the VCU is authorized by OEM and authentic too.